Okay, what we're talking about today is lesson 13, calculating and comparing square roots. A perfect square is a number that is the square of an integer. So for example, they give us 2 radical 2 here, and this is 2 multiplied by 2, which gives us a perfect square. We have these 2, and we have these 2, which gives us 4 for our perfect square. Same thing happens here. We have 3 times 3, which gives us a perfect square of 9. Okay. For our notation, they tell us that this is the radical symbol. I expect you to call it the radical symbol. It is also sometimes known as a square root, but for some of the things that we'll be doing, we'll refer to it as a radical instead of a square root. So it also says that a radicand is the number or expression under the symbol. So anything that is inside of that radical symbol is called the radicand. The square root of x, written radical x, or square root of x, is the number whose square is x. So for example, 4 squared is 16, so the square root of 16 is then 4. Example 1 says, is the radicand 200 a perfect square? Well, there's a really obvious quick way to figure that out, and that's by using your calculator. However, think about some things that we know. Some perfect squares that I expect you to already know is, for example, 100. 100 is a perfect square, or is a square of 10. Okay, so 100 is a perfect square. Is there anything times itself that's going to get us this 200? And the answer to that is no. If you punch in radical 20 into your calculator, not 20, excuse me, 200, you get 10 radical 2, or some crazy 10 or decimal something crazy, okay, which means that it's not a perfect square. If it's a perfect square, when you punch this into your calculator, you are going to get an integer. Is the radicand radical 225 a perfect square? Now that maybe isn't one that you know yet. Eventually I expect you to know it, but whenever you punch that into your calculator, you should get 15. And if whenever you punch something into your calculator, or punch a radical into your calculator, if you get an integer, which 15 is an integer, then that means that it is, whatever that radicand is a perfect square. So it says, estimating square roots, list the first 20 perfect squares. Well, we start this by squaring our integers. So the first one we would have would be 1 squared, which is 1, 2 squared, which is 4, 3 squared is 9, 4 squared is 16. I want you to continue this for the next 20 in your notes. So go ahead and pause for you to write out the first 20 perfect squares. Okay, so example 2 says to estimate the value of radical 75 to the nearest integer. So some different ways that you can do this. First of all is by using the perfect squares that you should now know from the 20 that you listed out. Radical 75. Is this a perfect square? Obviously not, because you don't have it in your notes, but we're going to find out the perfect squares that are. So I know that to the left of 75, the nearest perfect square that is smaller than 75 is radical 64, and radical 64 is 8, or the square root of 64 is 8. So this is less than radical 75, which radical 75 would then be less than the thing on the right side, which would be 1 more than 8, which is 9 squared, which is radical 81, which gives us 9. So I know that it falls somewhere in between these two things. The question is, which one is it closer to? Okay, so to get from 64 to 75, I have to add 11. To get from 75 to 81, I have to add 6. So that tells me that the nearest integer is actually 9. Now this is the process that I expect you to show me your work on. However, you can absolutely punch this into your calculator and check yourself. Whenever you type in radical 75, well, this calculator is set to a different mode. Let's see. Alright, so whenever you type in radical 75, it gets you 8.660254038. And you know that to round that to the nearest integer, you have to round it to the nearest whole number, which is going to be 9. Wants us to compare. Before we can compare these things, we have to find out the square roots of each. So I have radical 81, which gives us 9. We just talked about that one. Radical 16, or the square root of 16, is 4. I'm comparing this still to radical 25, which is 5, plus radical 4, which is 2. 9 minus 4 is 5, compared to 5 plus 2, which is 7, which means that our answer is greater than, so it's less than. 5 is less than 7, which means that this one would be less than. And I think, this is the last example. Okay, so it says a shopper got a bargain on 256 brick patio tiles, each 1 foot square. So they got 256 tiles that are each 1 square foot. So that's a total of how many square feet? I hope that you're thinking 256, because that would be what it is. And it wants to know, what is the side length of a square patio made with these tiles? So if I know that my patio is a square, I know that I'm using 256 square feet, or square tiles, to cover this patio area. So whenever I do this, I can think of it in a couple of different ways. First of all, the area, to find the area of a square, we should know that that is area equals side times side, which is side squared. And I know the area already is 256, and that is square feet. If I plug that in for A, equals S squared. Well, S squared, I want to know S. I want to know what is the side length. Okay, I don't want to know what the side length squared is. I already know that. So for a square to cancel, I hope that you can remember from your pre-algebra days that the opposite of squaring is square rooting. So we would square root. What I do to one side, I must do to the other. And radical 256 gets me 16, and it's just 16 feet. That's your final answer. I hope that you've taken good notes, and I will see you in class tomorrow.